Ça, c'est juste l'intro du workshop que tu fais.
Ah oui, ok. D'accord. Oui, mais je n'avais même pas...
Oui, non,
je ne l'ai pas
préparé
préparé du tout. Okay. So, welcome everybody. So we are happy to welcome you on a subject which I think very interesting for the future, which is the sustainable and resource-efficient solution for cultural heritage. We have 3 projects: Heritage, CALECHE, and Inherit. Here you have the list of presentation. So you present.
Yes, I will present.
Okay, the objective. Then Antonia Vronti, it's you. Okay, so you present the Inherit approach. Then we will have Elodie on the air tightness. So who is also partner from CALECHE project. Arno Jensen will present us Heritage project. And then I will present the PV integration that we have done for the CALECHE project, and then we can try to discuss together. I think it's very interesting to have a look on other projects. We are focused on our project, and I shall present you. And it's very interesting first to know that there are other projects. We already have some exchange, but I think that the workshop is an occasion first to discover the other project, and then I hope to find how we can collaborate and to find some links between our project, which is something very important for the Commission. So I'm Etienne Wurtz, coordinator from CALECHE, and also researcher in CEA and scientific director of INES, which is Solar Institute in France in Chambéry.
I need to change slides.
Okay, and so.
Okay, thank you. So I will start. And just a quick reminder, if there is some people online, you can ask questions on the chat, and we will answer to you. So I'm Rachel from R2M Solution, based in France, and we are working in this CALECHE project that I will present to you. So CALECHE stands for Coherent, Acceptable, Low-Emission, Cultural, Heritage, Efficient Renovation. And just a quick reminder why we are, this is a challenge to renovate historic building. So far the renovation rate of the existing building is super slow, around 1%. There are many difficulties. Difficulties in finding a suitable technical solution, difficulties in involving users in the act of renovating those historic buildings, difficulty in reconciling all the criteria required to make the decision, like the energy, but also the cultural value, the safety, the inclusion, the environment. And the last one, difficulty in having those technical solutions validated by the conservation authorities. And this is what has been theorized as a smaller negotiation space for historic building compared to a common existing building. And last of the obstacle, the energy retrofit solution for historic building are neither purely technical, neither purely social. So it's a mix of those both things that need to be analyzed and to find the best solution. So as you see, lots of challenge that we try to tackle in CALECHE project. First of all, I want to present very, very briefly the team that is working in this project. We have diverse type of company. We have research institutes, universities, architect, industrial, association, and consultant. Technical consultant, but also innovation management consultant. So what are we doing in CALECHE in our multi-benefit and multi-target concepts that I will present to you? Our vision is to boost the renovation of historic building And our mission is to work on trigger points to unlock the renovation of historic building, and to put human and social approaches at the heart of the process. And how we want to do that, what are our objectives? We will introduce innovations both in governance and social approach, but also on technical improvement for products and construction process. Each of those aspects, innovation will follow a multi-benefit approach, and the project promotes both the low-tech renovation aspects, we repair over replacement, while leveraging on advanced technical solutions like digital tools and historic building modeling, BIM to scan, artificial intelligence. So that's the broad scope of CALECHE project. On how we will tackle that more concretely, we have two complementary work scales. We want to develop an historic renovation hub where we will host a decision support system that will help the owners to find the most suitable solution for his historic building. So we will have this decision support system with decision trees, but also we want to put there a stakeholder engagement process, and all the stories and success story and will be put also in this historic renovation hub with a repository of selected products and solutions. That's the first scale. The second scale is on product and technique breakthrough. And we have basically three main topics. It's the customization of BIPV specific for historic building, the bio-indoor insulation for historic building, and the historic wooden window retrofit protocol. So that's our three axes of product techniques. And we want also to have a package of system of those solutions. So not only those three ones, but all the one we have included in this historic renovation hub. So those two scales will be kind of tested on 4 pilot sites, you know, to have some real-life validation of CALECHE developments. I will start first with the historic renovation hub. What we have done to prepare the development of the decision support system of CALECHE. First, we have done a very broad literature review of what we called decision support system in building, in historic building, in process. So we have this broad overview of all the existing tools related to the retrofitting, and we have then evaluate those existing tools to define where are the gaps, where are the important aspects of those tools. And that have helped us to define our own decision support system process. So now we have decided to have this 4-stage process. The first one is to have, you know, the contextual information of the building. Then is to have the data gathering and input of the building. So both with stakeholder survey and technical inputs. And then we will have our algorithm that will narrow the solution shortlist. So we will develop an algorithm to then have package of solutions with a plural, because we don't pretend to develop a tool that will give the solution that will be the most pertinent to renovate your building, but we will suggest the most pertinent solutions. So we will narrow the solutions. So that's our idea behind this decision support system. Then in gray, so it will be design, implement, and assess outside the historic renovation hub. And finally, we will have another stakeholder survey that will be made also in the historic renovation hub to give feedback and to maybe improve the maintenance over time and so on. So that's the DSS process that we come up after 1 year of the project. Here, in terms of inputs of outputs, so as I said, there will be questionnaires from the owner and stakeholder, but we will have also information from the owner on the setting of the building, the context, And also it will be possible to have technical inputs, for example, energy audit or evaluation of the building, or structure evaluation and so on. And all those inputs will be analyzed through algorithm. We are trying to use the potential artificial intelligence to process some of those data. And the output will be a report of all those information in a nice way to really understand what are the characteristics of your buildings, and to have in one place, in a nice way, all the information of your building. And then, as I said earlier, we will narrow the possible solution that you have when you want to decide to renovate your building by providing a generic solutions repository with some scoring across values and uncertainty rating. So it really is to support the decision system of the owners and the people who want to renovate their building. A bit more of information of which kind of input data we will have. So as I say, the seating and contest, but also the use, the scale, the scope, the condition, the heritage value, the comfort, well-being, energy, carbon, and resource. So all those aspects. And here you can see which kind of actor can provide those information. And as I said earlier, it will be based on a multi-benefit evaluation. It will be the algorithm. So it still needs to be developed, this algorithm, but it's multi-benefit. So we have cultural values, we have social values, we have economic values, and environmental values. And for each of the values, we have defined some key categories and lots of criteria. They are not all here. But we have started a first list of all the criteria on which we want to evaluate in a multi-benefit way the solutions that will be in our repository. So that's for the presentation of the DSS algorithm and process. And in parallel, we are collecting all the solution, possible technical solution that are really specific for historic building. So here you can see some example of windows. So we start this big database that we try to have more and more information on each category of product. And the idea after that, maybe some of you already know this platform called Hyper Atlas, which is from another past European project. And the idea is to put our solution repository on this Hyper Atlas that is already existing. You know, is to link the CALECHE project with the Hyper Atlas existing repository. Now we change of scale. We go on the products and techniques pillar of the project. So as I say, we work on bio-insulation. And really here we start from scratch, studying a lot of different possibilities on blinders, aggregate, additives, and vegetable waste. So we have a partner in Italy working on that and doing a lot of different tests. We work also on the methodology to repair windows, so I will not go through too deeply because Elodie here will present it more deeply. And the last one is the customization of BIPV for the historic building. So here again, we develop a process. We see the TA develop a process to trying to study the possibility for PV. So it's not only the technical possibility, but also the acceptance for the inhabitants around the building. And we are maybe trying to also to push some new standards or regulation to make it more easy for further operation. But we are still at the very beginning, so let's see how it's evolving the project. So that was the two pillars of the project that we test on 4 diverse use cases. So one is in Italy, this villa in Italy with its garden. Another one is the neighbor in Switzerland. We have this building in Sweden, and another one is a museum in Grenoble. So I don't know if I still have time, but I can show some pictures of those two of those pilot cases. So this building in Italy, it's abandoned so far, and the intended use after the renovation is the socio-cultural activities. The studio is lying on the villa plus the garden, and so that's the condition inside the building, and it's the whole area included around the villa. And what has been done so far, so it's already done the laser-scan survey of the building, the photogrammetric survey, the HBIN architectural model. And as you can see on this picture, so it's how they have done the 3D survey, and with all the points, on the villa, and how it has been remodelized, these 3D models. And they are trying also to so inside and outside, and they're trying also to bring some more data and values in these 3D models to have an historic BIM model of the building. So it's still under process, but here they have a bit more 3D information. But the goal is to be more and more precise, to have an efficient BIM model. So yeah, it's in process. We have a lot of other activities that we will be involved in this pilot case in Italy, with all the tools that will be tested, all the process and tools of the DSS that will be tested also here. And in Visby, so it's a small island in Sweden named Gotland, and Visby is the city where all the city center is of historic value. And here it's a merchant building, and for the moment is in use. It's the housing of the regional tourist office. And as I say, all the city center is of interest, And so it's the current picture of the building here, but back then you have a totally different shapes. So when renovating, there is question: do we have the flexibility to go back to this shape? What can we do with windows or not? We see that the windows are the same. So yeah, it's the evolution of this building over time. And what have been done so far with this building, the energy optimization in 2017. And there is some recoloring of the facade, window refurbishment, but really here they really want to increase the efficiency of the window refurbishment, and to include the community, the local community on this challenge, and they wish to implement BIPV. So definitely CALECHE will help to do all those studies. And some, collaborative workshop already happened. So yeah, that was the presentation. Only of the two pilots. Like this, I can show you more pictures. I don't know if you have questions. Otherwise, I give the floor.
Are we doing questions now or later?
Yeah, we can have questions now. Yeah.
Yeah, I have one. I'm involved in two heritage projects. One is Heritage for Ages, which maybe is a sister project or not, I don't know, I'm not sure, but one of my concerns is the digitalization, so the creation of these HD models. Maybe in Northern Europe it's quite standard to have HD models, but in Spain, Portugal, Italy, I think we can assume that there are no existing HD models anywhere, unfortunately. So my question is, have you worked on standards or standardized methodology for the HD model development? That's one question. And if so, is these methodologies public or whatever? And the other question is, are you intending to use HD model data for things like energy optimization, energy simulation, LCA, LCC analysis?
Okay, I will start with this second question because really our research question in the CALECHE project is to understand whether or not to have a BIM model for an historic building is worth it or not, because it's a lot of effort, because it's way more complicated than in a conventional building. So you put a lot of effort in developing this model. If you want to use it for LCA and energy model, it's even more complicated. So we do it only on one building, on the Italian case. We're trying to do it. And we analyze the efforts that we put on that, and we will compare, okay, in the end, all those efforts, are they worth it compared to what we can achieve without the HB model, but our conventional renovation approach that we will develop in CALECHE? And that will be the purpose of our project. So far, I do not have the answer. So we are trying to do that in Italy, and we will compare that to what we have done in the three other pilots. And we'll see at the end of the project, because it's really in the projects, some of us are really, pushing, it's really important, it's essential, it's the future, we need HBIM for each building. And some of them, no, it's too technical, historic building is way too complicated. So, yeah, we will analyze that. And so far, I'm not involved in the BIM model, so I don't know exactly which method they use. I think it's conventional, classical standard aspects, but I can ask and give you more information.
Sure.
Okay.
I think we didn't say that one thing is important. We are at TRL 5 for the project, so that doesn't mean we will have a tool at the end of the project, and doesn't mean we will have a building renovated at the end of the project. We discuss about a methodology, like Rachel said, which linked technical aspect with social aspect, and the idea is how we can drive the owner or the political people to know what we can do with the building and which kind of renovation is needed, depending on what we do. And that's what is, for me, the most important is if, for example, if you have a very old building, you say, yes, it's very nice for a museum, but a museum, you need a very interesting moisture and humidity and temperature control. And so it's not old building which is the best one for that. Yeah. And so you have to think about the issue about you plan to do a renovation, but how will you use, and if you want to use it as a museum, that for the technical renovations there are a lot of things to do that you will not do if you want to do, I don't know what you can do, a data center or something like this. So the real question is how can we mix the technical and the social at TRX 5, and so for sure we will not have the method with application to propose. But we explore the BIM, we explore the technique, we explore the rehabilitation, we explore the PV, a lot of things, the windows, and it's more.
And all results will be available online, so it's. Okay, thank you. If there is no other question, we can go to the next presentation.
Maybe just a timeline.
Yes.
It's also started this year.
In October last year.
Yeah. It's the first year.
It's the first year. Yeah.
Hi everyone. Good afternoon. My name is Antonia Brondin. I'm from Singular Logic, the coordinator of Inherit. And today I'll give you a short overview, including the aim, the pilot sites, and the methodology that's divided in 3 layers: the social, the scientific, and the technological. You might find similarities with CALECHE. It's a sister project to Inherit. So similar as Rachel said, there might be some challenges sometimes sometimes in order to restore and preserve these kind of buildings due to their vulnerability and their age. So we can see that it's sometimes little accessible by citizens, and they can eventually find new uses if we make the correct renovation actions. So the project, it's also been running for a year now. It started in October 2023, and it aims to offer a methodology that will make historic buildings more energy efficient, accessible, and sustainable while maintaining their cultural heritage value. These are our 8 pilots. We have in Spain, in France, in Poland, in Latvia, in Croatia, in Turkey, in Greece, and in Sweden. The interesting part is that in Sweden we also have Visby, but we aim to demonstrate and validate the methodology in the whole city of Visby, and it's protected by UNESCO. So, as said before, the Inherits methodology is divided in 3 layers: the social, the scientific, and the technological, and it's in line with the new European Bauhaus principles. I'll go one by one, each layer, and I'll give you some examples of our progress until now. So in the social layer, we use the social sciences and humanities to produce real-world impact. We use the multi-stakeholder approach to point out the needs and interests of potential users and stakeholders like architects, facility managers, and so on. And we have the co-creation process, which is based on the social labs and the multi-stakeholder forums. As you can see here, I would like to focus on the co-creation, where we have completed the first cycle of the social labs, where our pilots had the opportunity to meet with stakeholders and receive feedback based on the needs, the barriers that might be faced. And the second round of the social labs will start by the end of October, which will be more based on the technical aspects and the new European Bauhaus. We have the scientific layer. We aim to set up a European common approach to achieve a balance between the sustainable building performance and heritage values. We use the assessment and monitoring framework to evaluate these sites. And we are creating a hub of measures to define affordable and viable solutions to renovate the buildings. Here we have, in August we had the first release of our Inherit Assessment and Monitoring Framework. As you can see, it is based on the methodology. So we had the technical inspection. We have decided to use the pyramid methodology, where you can see the facades and roofs and foundations and structure on the lower levels, meaning that they're more important in order to prevent collapse and ensure the safety of the users. And on the upper layers, we have the installation, accessibility, and the functionality of these buildings. Then we had our first release of the framework. We have developed a list of KPIs that are divided in 4 pillars: the energy efficiency, the resource efficiency, the climate resilience, and the accessibility and sustainability. And this framework has been transformed into a tool where we had also the first release. It's a very small picture, but it shows the 4 layers, and where this tool, basically you can input your insights and it gives you the results of the building that you are testing, and the hub of measures in order to manage and modernize these cultural heritage sites. We have identified 83 measures, and 37 out of them can be applied to high-level protection cultural heritage sites. Last but not least, the technological layer. In Inherit, we will develop 11 services that are divided in 4 key areas: the data collection and sharing, design and renovation, monitoring, operation and management, and preservation and maintenance. As you can see, the first column has the 4 groups, the second, the services that will be developed, and their relation to the pilots. Service 0, smartification and data exchange platform, and Service 3, decision support tool for optimal renovation planning, will be applied to all of the pilots, whereas the rest of the services are divided based on the needs of each pilot. And of course, within Inherit, we don't only aim to apply our methodology in these 8 pilot sites, but we aim to replicate. And these are some of our planned replication activities. We want to replicate, as said, the methodology in other cultural heritage sites. We want to develop new decision models and guidelines for policy makers. We aim to create training material and capacity building program to share the collected data, to adapt and tailor the Inherit solutions, the 11 services, to other buildings based on their needs, and to create new international standards for cultural heritage management. The consortium consists of 18 partners across Europe, and I think it's a promising project, and we're looking forward to our next milestones. Thank you. You can find Inherit on this QR code. Any question? Yes.
Are you also TRL5 in your project?
Sorry?
The technical readiness level, is it also 5? Will you have some real project at the end of the project, or like us in CALECHE?
It was the same course, so
same course in TRL. Okay.
But yes, the question is, what do you do with the demonstration?
What do you mean? What do we do?
the pilot you planned, they are already renovated. They will be renovated during the project, or the renovation or planned after the project?
She's a pilot representative, so.
We will test the tools and we will propose the renovation design to the owner of the building, for instance, in our case, the municipality, and then later it's like they will decide if they will go for the renovation, but renovation itself is not part of the project. We didn't have money for like activities, physical activities. It's more testing various tools, adjust the design to the needs of people of the building, because also the cultural heritage buildings are a very big group, and we have buildings on which are under protection, and you would never tell me that it's a cultural heritage building, and also on the other side we have castle, monasteries, churches. So this group is very big, and also different renovation activities are possible. So the idea here is to test various tools and to, for each of the building, propose and see what is possible, because different kind of intervention will be possible for different kind of building depending on the needs. And
we also have the hub of measures.
The same for CALECHE, but no, because I have seen that you have different projects with the different pilots, and they are not the same objective. But there is no renovation plan with these 8 demonstration sites.
At this moment, there is no concrete. We are supporting to develop and pass them. So finally, the owner of the building can decide, but has something already in their hands, So sometimes I know from at least our experience, when we pass the renovation design already somehow agreed, this facilitates the decision for making the renovation itself, because there's already something done, yes? The process is initiated, so it's really much more easier.
Could I know the partner or partners responsible for the digital twin development, sharing platform?
Who is responsible for the digital twin? Semosa.
Semosa, okay.
Mm-hmm.
From Spain.
Yes. But we also had some issues with sensors on some of the monasteries, and one of the pilots is in Spain, in Valladolid. They couldn't install the sensors, so we are trying to figure out another solutions. Maybe we can we could change the service that will be implemented in that building.
And in terms of data exchange,
Yes.
are you finding issues or barriers in terms of ontologies, formats?
Sometimes they don't give permission for data sharing, and if this is your question, if I'm
Yeah, maybe more focused not to privacy, but to like the technical barriers.
Yes, this is a problem. We cannot install sensors and so on to receive the data that we want. So this is a challenge for us. This is why I said that we think of like changing the service and implementing something that does not need any tool or sensors and so on.
Yeah, I think also valid comment was what I think you told before, that the variety of the building is so large that for maybe some of them the beam is worth making and really the owner can use it later, while for some other not. So there is no clear answer, one answer valid for all the cultural heritage building, yes or no. It really depends on the building, on the concrete example, yes. And also I believe that with the time this technology will be cheaper, so somehow it will be a must, yes. Maybe for the building now that we are constructing, that within some years will be also under cultural heritage, but now we don't consider that. But I think thanks to our project, at least I can say that municipality of Gdynia, because also in Poland the digitalization means BBM, to be honest. So they are also learning this, yes? So they see, okay, there is something like being, what does it mean? What information can be behind? What metadata? How I can use? Because sometimes their problems are very very, but we don't have a software, we don't have a computer. My computer is so slow that I'm opening Excel for 1 minute or whatever, yes? So, that change, it's a process, it's not like this, but also they are learning and maybe making some trainings towards it. So it's like many different benefits, and sometimes the answer is not so straightforward, that after this project, I don't know, whole Gdynia, whole city will be digitalized, but sometimes one is like making the room more.
Okay.
Thank you.
Yeah, I think it's Elodie now. No, someone. Yes, Elodie.
Hello everyone, I'm Elodie Eberle. I'm from CEREMA in France. I'm a building physics engineer, and I will present you what CEREMA is doing, a part of what CEREMA is doing in the CALECHE project on the subject of the measurement of airtightness of historic wooden windows. First, I have to present CEREMA. we are a kind of engineering office of the Ministry of Sustainable Development. And we are working on several fields, building, but also mobility, transport infrastructure, environment and risk, sea and costs. And in those fields, we do transversal activities. One of the most important is support for public policies for municipalities and for our own ministry, but also innovation, research, and international projects like CALECHE, and standardization in our fields of expertise. In France, we are 2,000, and we are located everywhere in France. And in our fields, we are specialized. So, for example, in Strasbourg, where I come from, we are specialized in energy retrofit of historic buildings since 2007. And we have done a lot of projects and studies, research projects, but also studies for our ministry, regions, etc. And we have met a lot of partners. And with those partners, we have launched in 2016 a resource center that is called the CREBA, and in which we gather information about our topic of energy and heritage. So you can access to it freely. It's in French. And you will find some examples that show that it is possible to have energy efficient buildings while maintaining their heritage significance. We have another agency in Autun in Burgundy. They are specialized in the measurement of buildings' envelope airtightness. So for those who don't know what it is, you see in the picture that it's basically a fan that you are installing in the front door of buildings. And the fan is pushing air into the building. And the device can calculate how much air is going outside through the cracks between the building components, between, for example, the windows and the walls, the walls and the roofs, etc. So you can have an indication of the performance of the building envelope about air leakages. So that's their own field of expertise. You see two devices, one for the normal buildings and the other one, the big fan for big buildings. And CALECHE was the perfect project to join our two expertise, and that's why we are working on the measurement of airtightness of historic windows. This activity is part of one of the tasks of CALECHE, and we are CEREMA is pilot of this task. It's about the development of a protocol for the assessment and the retrofit of those windows. You could say why we are so interested in windows. I think it's the same in other countries, and it's not only in France, but windows are mistreated. We were aware of that because we are meeting a lot of heritage architects, and they are very sad about the loss of all these old windows, historic wooden windows, because they are in bad condition. No one wants to repair them, and they are replaced by plastic windows that have no heritage value, and that's a shame for them. And we want to give them some scientific assessment, scientific and objective arguments to convince their clients that maybe repairing is possible, maybe replacing glasses is an alternative, and maybe sometimes you have, of course, you have to change the windows, but not in all cases. And I found a quotation of Le Corbusier. He said the entire history of architecture is the history of the struggle for light. So that's explained for me as an engineer. That it's not my field, but it's explained why architects are so in love with windows. So what we want to do in this task is to do what a heritage architect could do when he has a retrofit restoration project of a historic building. And we would like to have some kind of holistic assessment of the state of the historic windows. What is its condition? What is its heritage significance? And what are its technical performances? We want to focus on three technical performances: airtightness, of course, so heat losses through cracks between components; U value, that is heat losses through the components in itself; and life cycle analysis. About U value and airtightness, we plan to do on-site measurements with our devices, specialized devices. For the U value, it's a device owned by URAC Research. That is another partner of CALECHE. It's basically a box that you put on windows, and then you have the U value, the thermal coefficient that is given. And for us, it's basically the same as the devices I'll present you for the buildings. It's a little fan we put in a window, and then we push air into the cracks of the window, and we can see where there are air leakages. And after repairing the window, we can see if the indicator is better, etc. And yes, that's all about this subject of heritage windows. If you have questions, I'm happy to answer. Yes?
Just had a question on the devices.
Yes.
Those are meant to measure on site?
The one for the URAC Research is will be developed to go on site. Our own is already used in new buildings on new windows, and it needs some adaptation because old windows have more leakages, and so the fans are not enough powerful. So we need only an adaptation, but our device is already used on site.
And how do you manage to accommodate different dimensions
of windows? Yes, we have we have a system. It's the same system with the blower door, the device for the building. You can adapt with a frame. The frame is you can make it longer, and then it goes it press on the table of the windows. And it's going to 240 meters long and 160 meters wide.
And that's the same principle for the hotbox?
The hotbox is a little less adaptable. Mm-hmm. Okay, thank you.
Yes, good afternoon. So my name is Arnold Janssens. I'm a professor in building physics at Ghent University, the Faculty of Engineering and Architecture in Belgium. I am project coordinator of the project Heritage. I also acknowledge the project managers, Eline Himpe and Klaas de Jonge. And as you see, the Heritage is an acronym for future-proofing heritage townhouses by optimizing comfort and energy in time and space. And that already shows that we, in this project, want to pay attention also to the heating and ventilation systems and the control of these systems and the energy systems in general. And before I forget, I also brought some flyers with me if you're interested to have a short overview of the project content. You can find them there. My presentation will be more or less have the same structure as the previous presentations. This project started in the beginning of this year in January. We had a kickoff meeting in February. Next month we'll have a second consortium meeting, and in between we had a lot of web meetings, but just to say that we're only in the beginning, and I will mainly explain what the objectives are and give some intermediate results. So this project is also a research and innovation action project within Horizon Europe, so that this means it's not demonstration. We're also working at TRL levels 4 and 5, and this is one of two projects from the call, Future-Proofing Historical Buildings for the Clean Energy Transition. Our sister project is Future Hist, which is coordinated by URAC. So we'll be running for 4 years with a budget of 4.5 million euros. We are coordinating, but we have a lot of partners to collaborate with. We have 17 partners from 6 countries in Europe, as you see. Just to give you an overview, so we also have a combination of expertise. We have research institutes and research groups in universities from an engineering background, building engineering, energy systems engineering, like KU Leuven, Taltech, Sintef. We have research institutes with an architectural and conservation expertise, like Politecnico di Milano and NICU in Norway. We have industry like Sacred, Desmaris. There are engineering companies like Sweco, conservation authorities like the Heritage Council of the City of Ghent, our city, and the National Heritage Board of Estonia, and then some spin-offs as well like ZH and Buildwins, and communication partners, dissemination partners like ACE, the Architects Council of Europe, and LGI. So this is in an overview the expertise we want to bring together in this project. Unlike the other projects, we have defined a specific typology to analyze, to investigate. So this was also the objective of this call. We had to define a typology with which we can target the renovation of a substantial degree of the historical patrimonium in our countries, in our participating countries. So we are looking at heritage townhouses, which, as you see on the pictures, represent the facades of our historical cities. So they constitute a significant proportion of the building stock. We're looking at those houses used as dwellings or as small commercial or office spaces, and target those buildings which were constructed before World War II. We have 4 case study cities, Trondheim, Tallinn, Ghent, and Mantova in Italy. Well, the definition of these heritage townhouses in the different countries are a little bit different, or let's say the construction practices. In Belgium, we mainly have masonry townhouses for single families. In Estonia, they rather look at multifamily buildings. So there are some differences. Norway is looking at wood frame houses. So there are also small differences, but the common denominator are the heritage townhouses. So we face the same challenges as the other projects. There are restrictions in renovating heritage buildings, certainly for energy renovation. So we need specific approaches to develop renovation concepts for those buildings. So we have 2 main objectives: develop an overall holistic renovation approach for heritage townhouses, and you'll see we use a similar terminology as you have also seen in the previous presentations: holistic, multi-target. It comes back here, and we also develop specific innovations for our heritage townhouses at the level of the building envelope. So develop specific solutions for durable insulation and airtightness. For instance, windows is also a construction component that we analyze in one of our countries. At the level of the building, we look into optimized and smart controlled HVAC concepts. And we also look at the level of the district, where we are looking for renewable and residual energy sources that can be used to move those buildings towards fossil-free energy solutions. You see the different principal users that we are targeting with the outcomes of these objectives. Here you see the same words. We use different performance indicators. At one hand, of course, we look at the heritage value and how to preserve it. We want to improve the energy efficiency and move towards fossil-free solutions. Some of these targets were also defined in the call. For instance, we need to investigate to what extent it's possible to reduce the energy demand by 60%. With at the same time looking at cost efficiency, improving indoor environmental quality, taking the use of the spaces into account, and this also refers to the title of our project. We look at the durability. We don't want to have moisture problems, for instance, and also look at life cycle aspects, reducing waste, reducing material use, and that at the different scales, as I already explained, the building envelope, the whole building, and the neighborhood. And this is developed into a number of work packages. So except for the project management and the communication and dissemination, the work packages are dedicated to the scale that is investigated, the building envelope, the building enclosure, HVAC, and the district with the potential of renewable energy sources. And the outcomes of these different work packages are feeding into a work package in which the holistic renovation approach is developed, and all these findings, it's the aim to replicate them. Throughout these central work packages, we use a similar methodology, so we work on the same building types to make our analysis at the different scales. We will analyze the impact of different renovation concepts, which are tailor-made depending on the heritage value of the different components of the buildings. Analyze innovation aspects. For instance, at the building envelope in Estonia, our partners are looking into ethics solutions with historical renderings. At the building scale, in Norway, they're investigating how ventilation systems can be controlled in order to reduce moisture problems in their wood frame walls by including moisture sensors in the walls. And in work package 4, in terms of renewable energy and energy systems, one of the innovations we're looking at is model predictive control to better manage the systems depending on the needs of the building. And so then in the analysis and the performance analysis, we are mainly using simulation approaches, dynamic building energy simulation, to investigate how all these renovation concepts and control systems, energy systems will lead to an improvement in energy performance, reduction of carbon emissions, etc. To make this a little bit more clear, perhaps I can show you some of the typologies we are investigating. So just before summer, we had we had the first deliverable where each country and each target city defines the typologies which will be analyzed. In Belgium, we're looking at masonry townhouses from architectural and historical research. We've defined 4 main classes, which are used throughout all historical cities in Belgium, and which for the city of Ghent, for instance, represent almost 1/3 of the city patrimonium, and 10% of the city patrimonium are of the townhouse typology, one of those 4 typologies with a heritage value. That doesn't mean they are listed by definition, but they have a value in the city view. In fact, the listed buildings of this typology are a much smaller share of the total building stock. But this is just to show that it's a significant portion of the typical buildings we found in our cities. And so these typologies will be modeled, simulation models will be made. We're also looking at some specific neighborhoods in each of our towns in which these typologies are placed, just as a specific environment where we can investigate also how buildings within a district or within a street can be supplied by renewable energy from various sources. For instance, as in many city centers, we have rivers in Ghent as well. So heat pumps with heat from river could be used. This is, as I said, this will not be demonstrated in this project, but our engineering companies will look into the possibilities and the potential of these technologies. So that's the reason why we are also looking at very specific representative neighborhoods in the cities. So it's mainly simulation based, but some of our innovations will be tested in laboratory. Some of them, like the model predictive control, will be implemented in a demonstrator in one house. So it's all very limited, but we're exploring mainly the potential and the possibilities. And we also have some case study houses in which we monitor the indoor conditions, the energy use, have a survey of the people who live there to better understand the baseline and the conditions with which we can work in these houses. So that's a general overview. Thank you for your attention. Questions?
So concerning the renewable energy, you plan only to use the water, or you plan to use also?
No, well, we're looking into electrification, so trying to install heat pumps. So one of the first conditions we need to investigate is to what extent it's possible to use low temperature heating. So one of the tasks is also to look into hybrid heating solutions. which will depend on the limitations that we face in those buildings, depending on the heritage status. So that's the first question. Can we go towards low temperature heating? And then various heat pumps can be looked at, either air-based heat pumps. But when we look into district solutions, so collective solutions, water-based, river-based heat pumps is one aspect. The other thing we are looking at are geothermal heat pumps. Given the fact that in our historical cities and one of our districts we're looking at in Ghent, for instance, has an underground car space, which with the mobility policies in Ghent is less used than in the past. So the engineers are also looking at possibilities to use those underground spaces to harvest geothermal energy, as an example.
So to avoid the outside units.
Yeah, and to come to a collective solution which would serve with one big investment, but with one investment, many different buildings.
And you have a heat pump company in the consortium?
Not a heat pump company, but we have an engineering company like Sweco, who will investigate those concepts. Yeah. Mm-hmm.
Okay. Thank you. So we have a last presentation. So the last presentation. Okay. It concerns the use of the PV. So it's, as you have seen, we have chosen 3 applications. I think we should, and we discussed with an engineering company about a heat pump, but for the moment we don't have it, and we have only the insulation, the windows, and the PV that I will present you. My colleague Tony is in another room, but so as you know, I am working in a solar institute, and perhaps we have more sun, you have water in Belgium, and so we will see how we can use PV for the cultural heritage. So first approach, what we plan not to do, like we said, for the use case is more ID, and then applications that we can have in our centers. So we come back to the project, but considering the PV side, so I will probably say things that I shall already said, but the idea is to increase lifetime and to see how we can increase the lifetime for the building, and so how we can decrease energy consumption. And one of the way, because I think the first way is insulation, the second one is the windows, and the third one will be how we can propose a PV module on this kind of building. That has already been done, so you see some example, even in Vatican or in Berlin for the Reichstag, and for sure there are some possibility, and for that we have to look on the customization, and so we know that now we are able to have colored PV modules, a lot of possibility. So in the repository that we will propose in the Hyper Atlas, we'll propose some solution of PV, and we will see first application on the 4 use case. So I shall propose already this one. So that means at first to look about the possibility of PV integration. Then we need color, texture, specific texture, and to see how we can put them on building and then to design some prototypes. And just to know, at the beginning of the project, the idea for me was how could we propose PV on buildings, on cultural heritage. That was the idea before the call appears, and when we got the call, we had to look about the whole situation, but at the beginning, really, it was PV and cultural heritage. And so I think it's very interesting to look on these four first examples, because they are very different. One or two of them are more on building, another one is focused on a city, another one is a very old building, and so it's interesting to discuss about solution. And for sure, in Italy, it's a monument which is close to Pompeii, and so for sure we will not put a lot of PV on facade and everywhere. And the idea is how is it possible to have some non-visible PV. And in La Chaux-de-Fonds, which is a city in Switzerland, the idea is completely different. It's a city, and as you can see, it's protected by UNESCO. This neighborhood is very nice, but the idea we will see the PV and know the neighborhood is nice, and we will not, we want that it continue to be very nice after the PV. And so how can it be possible? And for sure we need colored PV and an ID, and the question, do we have some technical solution? So in Visby, I'll come back after, but it's then we need to find similar tiles as the tiles that are already put on the roof. And in France, it's still different. We have a steel roof, which no interest, but a very nice museum. And then we can put what we want, because the roof is not with tiles and is not a historical roof. And there are still other solutions. And for each use case, there are different solutions. And so the idea is to think about this solution and then to try to show some demonstration in our lab in Ines, because we have some possibility. So we are sure we will not put some PV on this roof. They will not accept at this moment, but we can show what could be interesting and to do some demonstration. That's the idea. So just discussing from the museum. As you can see, it's only an ID that you can see the PV, and the question is it possible that the owner accept this one? And for sure, we have a very, very large surface, so we can put a lot of PV on this roof. We have a lot of buildings like this in Grenoble, so if they're accepted, I think it's perhaps 10,000 square meters only for one building, and so we could put a lot of buildings like this. So that's the question that we have, and we need to discuss with the architect, with the owner, but also with the people, and to see if this kind of solution could be acceptable. We have also different kind of roof. We have glasses. We have steel panels, and so for each kinds of roof in this museum, we could propose different kind of PV. And so in the project, we are looking about what already exists on the market, what exists on research level, and what can be proposed today, what can be proposed after. So there are a lot of solutions which will be put in the repository, and so it's really the idea of the project, not only for the PV, but for all the technologies. Concerning the Italian use case, so the Italian, you understand that we need that this PV is not visible. So either we have solution to put it on the ground, like this solution. So could be a car parking, for example, or perhaps it's possible to put it on the roof, but nobody has to see it from the soil for sure. If you take a plane, you will see it, but it's not a difficulty for that. And to see what could be acceptable or not, and we plan to have some survey to the owner to know what could be possible. In Visby, it was another challenge. So the challenge was we would like, they are very old tiles because Visby is 12th centuries buildings, and is it possible to put some PV on the tiles that you wouldn't see? So we have all these tiles in Ines, and we are trying some again different kind of possibilities. The idea is really we don't see the difference with the actual roof and a roof with PV, which is today possible, but we have to prove that's really the challenge of this task in the project. So that's what I wanted to present you today. And as you have seen, it's based on the acceptance of the PV model, but already we were in La Chaux-de-Fonds, and in La Chaux-de-Fonds we try to imagine, is it real PV or real roof? And it's very, very difficult for some roof today to see the difference, and you cannot see the difference. So if you cannot see the difference, perhaps you can accept that it's PV on your roof. And we will have some application already in Switzerland, because the team from Switzerland is already working on this subject. And so we plan also to have some mock-up to show the new technologies of PV, like the new technology of insulation or new windows. And so the idea is to address to the authority to propose solution for the historic building. And so you have some example here to what could be proposed to the local authority to change the mind, because you know that today if you talk with an architect and you say you will put PV on your roof, they say, oh no, it's completely crazy. But as you have seen, in the Reichstag we have PV, in Vatican we have PV, so why not in this other building? It's only a first step to prove that PV can be very aesthetic. That's the idea of the project. Aesthetic, but also we have to monitor to be sure that aesthetic need also to get really energy, and its energy have to be an issue. It's not only it have PV for aesthetics, that would be completely crazy. So that's it, and what we are doing for the project. Okay, so we are at the end of the workshop. If you have questions, perhaps for the global workshop.
I just had a question on the tiles.
Yeah.
Develop these integrated PV into tiles.
Yeah.
Are the connections between the tiles, the electrical circuits?
Yes. That means so this exists already. So you have some tiles even for new building where you have connection for can be for each tiles or for 3 tiles or 6 tiles. That's something which already exists and which is behind the tile, so it's not a problem of aesthetics. The real challenge is to put some PV on the tiles and to keep the old tiles for this building in Visby. For the other, we plan to find similar tiles, but in Visby we plan to put PV directly on the tiles, and we should not see the difference because it's a very, very old building, and the authority would not accept to change even the technology of the tiles, which for sure don't exist anymore today. Okay, so we can close the workshop. Thank you for coming, and I hope that next year we will have a lot of results with all this kind of project, with all this technology application and also social application.